Hello students, welcome to the mathematics classes. Today we are going to study in a lecture factorization of polynomial equation. How to find out the factors of a given polynomial equation. So the method which we are going to apply to find the factors is called splitting the middle term method. So let's start. So to understand the topic, what we have taken is a general quadratic equation ax square plus bx plus c equals to 0. Here a is the coefficient of x square, b is the coefficient of x, and c is the constant term in the polynomial equation. So the first step to find out the factors of the given polynomial equation is finding the value of p and q. So we are taking two variables p and q. To find out the value of p and q, there are two conditions which needs to be satisfied to find p and q. The first condition is the sum of p and q should be equal to the b. And what is b? B is the coefficient of x in the given polynomial equation. And the second condition is product of p and q, p into q equals to a into c. In a and c, a is the coefficient of x square and c is the constant in the given polynomial equation. So by applying these conditions, we can find out p and q. So the second step what we are going to take is we are going to split the middle term. In the equation, the middle term is b, coefficient of x, in terms of p and q. So p and q we have already find out in step first. So the equation given is ax square plus bx plus c equals to 0. We have to just split this middle term b in terms of p and q. See, in the first step we have found the value of p plus q equals to b. We have found the value of p and q, and b was described as the sum of p and q. So he will do the same. So b will be split into p and q in the sum of p and q, and the rest of the equation remains the same. Ax square plus bracket of p plus q into x plus c equals to 0. So the third step what we are going to do is in this equation what we have derived till now, we are going to multiply this x with particular p and q. So the next step is going to be, if I multiply this x with p and then with q, the equation becomes ax square px p into x equals to px plus q into x, which is qx, and the c remains the same, equals to 0. So now our quadratic equation becomes ax square plus px plus qx plus c equals to 0. In the fourth step, what we are going to do is we will take the common terms. So now we are left with the four terms in the given equation. These four terms are ax square plus px plus qx plus c equals to 0. The first two terms are ax square plus px, and the last two terms are qx plus cx, qx and cx. So from the first two terms, what we are going to do is we are going to take common from the first two terms, and the same with the last two terms. We are going to take common from the last two terms. So from the first two terms, we see that the common is x. So after taking x, what we are left with is ax plus p, and there is no such common thing in common terms in qx plus c. In both the terms, there is no common. So what we can take 1 as a common. If there is no such common term or term found in the equation in the terms which we are going to take common, then 1 can be taken as common. So we have taken 1 as common, and the rest we are left with qx plus c equals to 0. See, what we are going to note here is, see, these two brackets we have received after taking common from the four terms. In this step, we are going to receive two brackets. First bracket is ax plus p, qx plus c. Second one is qx plus c. So Ax plus p and Qx plus c, we see that here both are different brackets. But when we are dealing with the practical quotient or practical polynomial equations, in those quotients we will find that these two brackets will always be same. This is also a condition to check whether we are proceeding in a proper manner or not. So here we are not getting the same brackets. The reason is we have taken too many variables. In the actual question, P, Q, A, B, C all will be constants. So there we'll find these two brackets will be the same. So for conveniency, I am taking one of the brackets as these two brackets will be same. So I am taking Ax plus P in spite of both. So Ax plus P will be common if these two brackets will be common. So I take Ax plus P. So taking common Ax plus P as it will be same as common, we are left with x plus 1 in the equation. So now we have two brackets, Ax plus P into second bracket x plus 1. So Ax plus P and x plus 1 are the required factors of the given polynomial equation ax square plus bx plus c equals to 0. Means these two are the factors of the given polynomial equation. So these are the steps through which we can find out the factors of a given polynomial equation. So let's take a practical example or actual polynomial equation whose factors need to be found out. So the question is finding the factors of the equation 6x square plus 17x plus 5 equals to 0. Here we can see clearly that in the previous slide we have seen ax square plus bx plus c equals to 0. Here the coefficient of x square is 6, means the value of a is 6. The coefficient of x is 17, which is b, and the constant term is 5. So a is 6, b is 17 and c is 5. So let's start with the steps to find out the factors of this given polynomial equation. So the first step what we are going to take is finding the value of p and q. How can we find the value of p and q is, we have seen in the previous slide that the sum of p plus q, we were bounded by the two conditions. First one was the sum of p and q was b, and the product of p and q should be equal to a into c. Here the value of b is 17 and the value of a is 6 and the value of c is 5. So the sum of p plus q should be 17 as b is 17, and the product of p and q should be a into c, a into c. A is 6, c is 5. So 6 into 5 is 30. The reason this is 30 is because a is 6 and c is 5. So by applying these two conditions for a given polynomial equation, the sum of p plus q should be 17 and the product should be 30. So what next we are going to do is how to still we are bounded by the conditions, but we haven't found the p and q. So what we are going to take is factorize this 30. Factorize this number 30, which we have received by the product of a and c. The factors of 30 are 2, 3 and 5. See, these 2, 3 and 5 can also be generally being also find out by taking the LCM of 30. So when we take the LCM of 30, the numbers which will be the factors of 30 are 2, 3 and 5. So now what we are going to do is we'll write 2, 3 and 5 and start making pairs of 2, 3 and 5 till we find our required conditions. Okay, so first we'll pair 2, 3 and 5 in such a way. So starting we are taking this 2, 3 as the first pair and we leave 5 alone. So by taking 2 and 3 as a pair and leaving 5 alone, 2 into 3 is 6 and 5 kept alone. So the product of 6 and 5, 6 and 5 is 30, and the sum of 6 and 5 is 11. So the first condition is satisfied. Uh, P into Q should be 30, 6 into 5 is 30. Okay, we are done with the first condition. But the second condition is 6 plus 5 is 11, which is not 17, which is required for this polynomial equation. So we cannot take this particular combination, or we cannot take 6 as P or 5 as Q. So let's take another pair. This time we are taking 2 alone and making 3 and 5 as a pair. So we have kept 2 alone, and 3 into 5 is 15. We have paired 3 and 5. So now we see that 2 into 15 is 13. 2 into 15 is 13, and our required P into Q is 30. Now we sum 2 and 15. The sum of 2 and 15 will be 17, which is our second condition. So by pairing in such a way that if we take first number as 2 and the second number as 15, the product is 30, and taking first as 2 and second as 15, the sum is 17. So both the condition, by taking P as 2 and Q as 15, both the condition, necessary condition of getting sum as 17 and product as 30 is satisfied. So our answer of first step will be P equals to 2 and Q equals to 15. So we are going to use these values, constant P equals to 2 and Q equals to 15 in our upcoming steps. And in second step, what we are going to do is, we will split the middle term. In the given equation, polynomial equation, the middle term is 17, which is B. We were splitting in the previous slide. We have splitted this coefficient of x, which was B. Here the coefficient of x is 17, so we will split 17, and 17 will be splitted in terms of P and Q. The value of P and Q are 2 and 15. So rewriting the equation again, 6x square plus 17x plus 5 equals to 0, the given equation. What I am going to do is, I am going to split this 17 in terms of 2 and 5. How? I'll write 17 as 2 plus 15. See, it matches the equation. It matches the first condition. P plus Q should be equal to 17, which is B, and we have found that P and Q to be 2 and 15. So writing 17 as 2 plus 15. See students, we need to keep this in mind, that the order of 2 and 15 is not important here. You can write 2 plus 15, you can even write 15 plus 2. The order is not at all important here. Okay, so do not keep this in mind that what order should be kept. Okay, it's free of the order. You can write 2 plus 15, you can write 15 plus 2. And the rest of the equation remains the same. 6x square plus bracket of 2 plus 15 into x plus 5 equals to 0. So the third step, what we are going to do is multiply x with the terms 2 and 5, 15. So in this equation, in the above equation, what we have received is 6x square plus 2 plus 15 into x plus 5 equals to 0. We are going to multiply this x with 2 and this x with 15. So the equation becomes 6x square remains the same. Multiplying 2 with x gives 2x. Now we are multiplying 15 with x gives 15x, and plus 5 is same, equals to 0. So the next step, so we have now the equation becomes 6x square plus 2x plus 15 plus 5 equals to 0. The next step is we are going to take common from the derived equation. So the equation is 6x square plus 2x plus 2x plus 15x plus 5 equals to 0. See how to take common. The common will be taken from the first two terms and the last two terms. The first two term is 6x square plus 2x. The common term from the 6x square plus 2x is 2x. So we are going to take common 2x from first two terms. We are left with 3x plus 1. Applying this plus sign here. And from the last two terms, we are having 5 as common from the last two terms. So we take 5 as common. We are left with 3x plus 1. 5 into 3x plus 1 equals to 0. See, I've spoken about the conditions of these two brackets in the previous slide, that these two brackets will always be same. Since this is a practical question, we have to find the factors of this practical mathematical polynomial equations. There were too many polynomials. There were too many variables. Sorry, a, b, c, p, and q. So that's why these brackets were not. We were not getting the same brackets. Here we are getting the same bracket. This shows clearly that all the steps which we have taken, first, second, third, and fourth, are totally correct. So it's also a method of checking whether we are proceeding in a proper manner or not. So just check, students, that these two brackets should always match while you are proceeding in this step. So if these two brackets are same, then we are going all right. So now what we are going to do is, we have seen these two brackets to be same. Now just from the from the four terms, we have reduced the equation to only these two terms, and even in these two terms we are left with a common term 3x plus 1 in both the brackets, in both the terms. So what we are going to do is, we take the common 3x plus 1 from these two terms. While if we take 3x plus 1 common, we are left with 3x plus 5. 3x plus 5 is another bracket equals to 0. So now what we are left with is just two brackets, 3x plus 1 and 2x plus 5 equals to 0. So these two brackets, 3x plus 1 and 2x plus 5, are the answer. Actually, they are the required factors of the given polynomial equations. So this is the process through which we can find out the factors of any given polynomial equations by applying these steps. So hope you have understood the lecture. Thank you for joining.